Hi, hello students. Welcome to Let's Understand Physics. So, have you ever observed while traveling in bus or bike, when the driver suddenly applies brakes, you will have a forward push. In the same way, when you are sitting in the rest position, when the bus suddenly starts, you will have a backward push. So these phenomena have you ever observed? In the same way, when the bus is taking a turn, you will feel, if you are sitting in the corner of the seat, that means last position, when the bus is turning, you feel you may fall down from that seat. Have you ever observed all these things? If you have observed, have you ever thought, why is this happening? Let's learn this today. So it is because inertia. It is because inertia. So what is inertia? We will learn what is inertia. So first, before learning inertia, about what we are going to learn, I have already used term called rest. What do you mean by rest? Means stationary. Or stationary means you can take it as not moving or stand still. Any of these terms can be used. If we generally talk about objects, so I will now call object. If the object is not moving, we say the object is at rest. Not moving in the sense with respect to certain reference frame. With respect to certain reference frame, if the object is not moving, that is called rest. We will discuss these topics in motion chapter. So those who are studying class 9, in the first chapter motion you have already learnt. Next time again I will teach you. Now I am just giving you rest means stationary. The object is not moving. And uniform motion. Uniform motion means the object is moving now, but the distances traveled and times taken to travel these distances are equal. I'm just writing keywords. The definition of uniform motion is when the object is traveling equal distances in equal intervals of time, we say the object is in uniform motion. If displacements also, same thing is applicable. Uniform motion means the object is traveling equal displacements in equal time intervals, then the object is in uniform motion. Now about rest and uniform motion, I hope all of you understood. Now, whenever the object is at rest or uniform motion, remember it is very important when the object is at rest or uniform motion, its acceleration is equal to 0. The body do not accelerate. Acceleration is equal to 0. Acceleration. So, you know, in bikes we have accelerator. Even in any vehicle you can say there will be accelerator. When you have this accelerator, why we use this accelerator? To increase or decrease the speed. Why do we use accelerator? To increase or decrease the speed. You know, right? That is the reason whenever you are trying to increase the speed of the vehicle or decrease the speed of the vehicle, you will use accelerator. Yes or no? So remember these three things. rest, uniform motion, and when the body is at rest or uniform motion, its acceleration will be equal to 0. Acceleration means when we have acceleration, whenever the body is increasing or decreasing its speed with respect to time. So this increase or decrease is generally called as change. Increase or decrease is generally called as change. That means whenever, if you are traveling with 90 meter per second, if it is changed to 100 meter per second, or you are traveling at some 120 meter per second and you have decreased it to 80 meter per second. So this is known as change in the speed or velocity. Change in velocity. So generally we consider here straight line motion, that's why we consider velocity only. So all these things you have already learned in your motion chapter. Now inertia. What is inertia? Why is this inertia term I have told you for these examples? Because when you were traveling in the bus, for example, there is bus on the road, the bus is going. Now when you are traveling in this bus, when the driver suddenly applies the brake, when the brakes are applied, you will have a forward push. If you have not observed this, you just observe when you are traveling in the bus. This is very easy to observe also. Suddenly when the brakes are applied, you will definitely observe this because you will have a forward push. Okay. When you are just sitting in the bus before starting, you are just sitting in the bus before starting the bus. You are here. Suddenly, if the bus starts, this many will not actually observe about this. When the bus suddenly starts, many do not observe. Next time you have to observe and identify. You are sitting here and you will have a backward push. You will go back and then along with the bus you will be moving front. Why is this? We are learning today. Now I have already told you it is due to inertia. Inertia means, for example, laziness. You can take it as laziness of the body. Laziness means what? If there is no force applied on us or any body, it doesn't want to change its position. It doesn't want to change its state. That means, for example, if you have to do some work or you want to get up early in the morning to go to school, to get ready, you have to definitely get up in the morning early. But until unless your mother wakes you up, you don't get up. Yes or no? That is the inertia we all have. That is the inertia we all have. We just want to sleep. We were in the sleeping position and we want to be in the same position until unless there is certain force applied. What is that force? That is your mother is calling you. That is the force, and you want to sleep but you have to get up. Understood? So that laziness, not only you, all the objects also will have. This laziness, all the objects also will have. So that laziness in physics, what do we call? Inertia. We call it as inertia. So why is this inertia? Why? Objects possess inertia. Objects possess inertia because of its mass. Because of its mass. Now, you know what is mass? Or if you don't know, you will learn in the next chapter, gravitation. Mass means the quantity of matter present in the body. What is the matter present in the body? We generally call it as mass. In detail, we will learn later. So, for example, we generally from the childhood we were using weight. Yes or no? We were using term weight. So, this weight and mass, both of them are different. Okay, we will learn the differences in the next chapter. Now, it is also with respect to mass. Understood? Weight you will get only from the mass. So mass means matter. What is the matter present in the body? We call it as mass. I hope all of you understood this. Now, small mass objects. For example, we take two vehicles. Okay. One is cycle and the other one is train, let us take. So, which has more mass, it has more inertia as well. Train has more mass, yes or no, compared to cycle. That's why train will have more inertia. In the same way cycle will have less inertia. In general, also you can take, if you have a ball, like plastic ball you just take, and you have another ball which is solid. I'll take just iron ball of the same size. Both the sizes are same but the materials are different. Which will have more mass? You know, iron ball will have more mass. I am just writing MP for plastic ball, in the same way MI for iron ball. So iron ball mass will be greater than plastic ball. So that which has more inertia? Iron. Practically also you can observe. Now on both of them you just apply equal amount of force. If you apply equal amount of force, which ball will be moved easily? If you are just touching also, your plastic ball will move. It starts moving. But iron ball, if you just touch, will it move? No, it will not move. Because its inertia is high. It has more inertia. That means it doesn't want to change its position. Whatever position it has already, it doesn't want to change. So that is the inertia of iron ball. So inertia is due to mass. That's why mass is the measure of inertia. Mass is the measure of inertia. Its SI unit is mass. SI unit itself kg, CGS unit grams, small g we have to write whenever you are telling total name gram, then you can say plural grams, but when you are writing just symbol you just need to write g. You are not supposed to write s here, that will be wrong. Next, what is the type of this whether it is a scalar or vector? So mass is scalar, yes or no? That's why even inertia is a scalar quantity. Whenever you are writing or learning about a physical quantity, you should definitely remember you have to learn its definition, SI unit and CGS unit, both of them, and whether it is a scalar quantity or vector quantity. If it has mathematical formula, you have to learn the mathematical formula also then and there itself. Then it will be easy for you. Understood? So that particular physical quantity name, its definition, its mathematical expression, its units, both SI and CGS units, and its nature, whether it is a scalar quantity or vector quantity also you have to learn at a time. Okay. Now this inertia is not allowing the object to change its position from its already position. Already in whichever position it is stayed, in the same position it just wants to stay. Now, this is observed by Newton. This is observed by Newton. Actually, Galileo also has observed, but in detail we have explanation by Newton. That's why Newton said, until and unless a non-zero resultant force non-zero resultant force. Non-zero means whatever the force is applied on the body should not be zero, and it must be a resultant force. We know on some object there will be many forces acting. Yes or no? There will be many forces acting. For example, if you just keep a ball on earth also, there will be gravitational force acting, there will be frictional force acting, and there will be wind force also acting. So upon all these forces there will be a resultant force. That resultant force should not be equal to zero. That's why until and unless a non-zero resultant force acts on a body or object, it does not change its state. Until and unless a non-zero resultant force acts on a body or object, it does not change its state. What are the states it does not change? State of rest or uniform motion. Only these two states it does not change. That's why in the beginning itself we have learnt about rest or uniform motion. In both of them acceleration is equal to 0. When there will be acceleration equal to 0? Whenever there is force 0. Understood? If there is no force, there is no acceleration. That this is the law given by Newton, and this is Newton's first law. I hope all of you understood. Whenever you have any object, if there is no net force, if there is some object of mass m, there is force applied which is not equal to 0, and this force also resultant force or net force. Understood? Net and resultant, both of them are same. Only in this case the object starts moving, there is some acceleration developed and it starts moving, there will be change in the velocity. So this change in the velocity depends upon the inertia, that is nothing but mass. If you have more mass, you should apply more force. If you have less mass, you can apply less force itself. Understood, all of you? So this is Newton's first law. This is also called as Galileo's law of inertia. Even Galileo also has given this. A small modification is done by Newton. So this is also called as Galileo's law of inertia. So very simple, very important this statement you have to learn, and after this inertia, and based on this you have so many examples. Examples are like when you have carom board, if you apply force on the last button, sharp force, last button coin, if you have applied when the coins are in a pile, only that coin will come out, rest of the pile will stand like that only. That is one example. Even on the table, if you have a cloth and on that if you have any dishes, if you give a sharp jerk on the cloth, only cloth will come out but the dishes will be there only. And when you have a pile of books, if you want to pull one paper from it, if you give a sharp jerk, only that paper will come out, rest of the books will stay there only. All these are examples. So you can observe in the carom board. So give a sharp hit on the bottom coin and the pile will stand there only. So it will be like fun for you. You can try that out. Okay. And even glass. Take a glass and take one cardboard and place it on that, and exactly in middle you just place one coin. Pull the cardboard, give a sharp jerk. You can observe the coin will fall in the glass itself. Okay. With this so many examples you can understand Newton's first law. So all these are because the object which is at rest, it wants to be at rest only if you are not applying force on it. This is the reason when you are traveling in the bus here. So this is the reason in these examples, when you were traveling in the bus, in this first case, you were at rest. Even bus is also at rest. Both of you were at rest. Your initial state is what? Rest. Suddenly if the bus starts moving, bus will get some acceleration. So its initial velocity is 0. Now instead of 0 it will get some velocity. For example, we'll take 40 km per hour. But you were in rest. You don't want to change your position. That's why you will have a backward push. Understood? Bus is moving front, but where you want to stay back itself. That's why you will have a backward push. In the same way, when the bus is moving with some velocity, let us take with the same velocity 40 km per hour, the bus is moving. When suddenly brakes are applied, what happens? Its final velocity will become 0. Then what should be your velocity? Along with the bus, you were also moving with 40 km per hour. So you don't want to stop. That's why you will have a forward push. Understood? This example you just need to understand. Bus is at 40 km per hour. When you are traveling with the bus, your velocity also same 40 km per hour. But here when the brakes are applied for the bus. That's why its velocity will come to 0 at the same instant. But what about you? You don't want to come to rest. Because of your inertia, you will have a forward push. Understood all of you? In the same way, direction. Same thing when the bus is taking a turn. You were initially going in the straight position. When it is suddenly taking a turn, you don't want to change your direction. That's why you will feel a push outward direction. You will feel tangentially outward direction push. So these are the three types of inertias. What are these three? These are the three types of inertias. Inertia of rest, inertia of motion, inertia of direction. The same questions can be asked by using horse also. Okay. So suddenly when the horse starts running, then you will feel backward push. When you are at rest, you want to be at rest, but horse is going front, so that you will have a backward push. In the same way, when suddenly horse stops, in films and all you will see, when suddenly horse or bikes stop, the person who is sitting on that, even in cars also, vehicles, they will go forward and fall down. So this is due to inertia, inertia of motion. Next, direction, same thing. You will observe while sharpening of knives. You will see the rays coming tangentially. In the same way, even if you have cycle or vehicles, mudguards also. You will observe when you are going in the mud will be coming out from the wheel in the tangentially outward direction. You can observe all these things. Even water also, when you are going in rainwater, you just observe next time. From any of the vehicles you can observe the water will be coming out tangentially. Okay, and comment and let me know if you know any other examples. So in this, whatever you have learned, you have to learn the statement of first law. I have just made simple. Okay, this is also correct. Until and unless a non-zero resultant force acts on a body, the body does not change its state of rest or uniform motion. So this is also correct, and it will be easy also to learn. In the same way, next you have to learn inertia definition. So the measure of inertia is mass. Inertia definition is the inability of the body. I am writing here. Okay. Inertia, the inability of a body to change its state of rest or uniform motion. So I have given here inertia definition. If you learn this inertia definition, you can write inertia of rest definition, inertia of direction, and inertia of motion. Okay, the inability of your body to change its state of rest or uniform motion on its own. So it cannot change its state on its own until and unless there is some non-zero net force acts on a body. Okay. After that, what is the measure of inertia? It is mass. Mass is the measure of inertia. It's SI unit and CGS unit, and it is a scalar quantity. And which has more mass, which has less mass. Based on that, you can tell which has more inertia and which has less inertia. So I hope all of you understood this concept and important points also, and examples also are very important. So without inertia you cannot do any work. If you want to throw any object also, you need certain inertia. See, for example, if you want to do high jump or long jump, you might have observed while doing long jump, your PET teacher will tell you to run from certain distance and come. Yes or no? That is due to inertia of motion. Whenever you are taking long jump or high jump, you need to get that inertia of motion. So suddenly you cannot stop. That's why you will get a chance to take long leap. Even during your javelin throw or shot put or cricket also. Cricketers while bowling, what bowler will do? He will run and come from certain distance to get that inertia. Just standing and throwing, he cannot throw that much distance. Okay. You also just try. You just stand and throw and run from some distance and throw. You will observe the difference. Okay. Long jump, high jump, all of them are same. Simply standing, you cannot take long leap. Run from some distance and take. You will have long leap. Okay. All these are due to inertia or if you want to tell in detail, these are due to inertia of motion. Okay, understood all of you? Thank you. So please like, share and subscribe to Let's Understand Physics for more concepts. So if you want any other concepts, you just comment and let me know so that I will do that. So next class will be on momentum. Okay, after that you will learn Newton's second law. Thank you so much.